All right, so now we're going to determine the limiting reagent when you have grams. Okay, so this is not moles anymore. You cannot just subtract grams from sulfur trioxide or grams of water and determine the limiting reagent from that. No, you can't, right? Because the equation doesn't say that 20 grams of sulfur trioxide react with 10 grams of water. It says 1 mole of sulfur trioxide react with 1 mole of water. If you want to do in gram, is what what's the grams of 1 mole of sulfur trioxide? 80.06 grams of sulfur trioxide will react with 18.02 grams of water. If you want to do in grams like that, okay? So grams and mole are totally different here. So we have grams. You cannot just subtract like we did in mole. That's my point, right? Well, what are we gonna do then? Well, we just convert grams to mole, and the rest you just do like normal. It's just one step further, basically. All right. So, all right, we can subtract like normal now because we have in mole. They are all 1-to-1 ratio. Looks like this sulfur trioxide have the least amount, right? 20 grams of sulfur trioxide is way different than 20 moles. 20 moles is much bigger. Okay, so 20 grams of sulfur trioxide can give only 0.2498 mole, which is about almost a half. Yeah, almost a half of the amount of moles of water, 10 grams of water. Okay, so clearly sulfur trioxide is used up. It's a limiting reagent, so use all of it. And if you use 0.249 moles of sulfur trioxide, what's the mole that we use here for water? 1-to-1 ratio, of course, the same number. And of course, the same number for the product as well. Okay. All right, use up the sulfur trioxide, so 0. Subtract here, so we have water left over. And we produce that amount of sulfuric acid. Okay. Excess here, there's a theoretical yield. Right? Who's the limiting reagent? The sulfur trioxide. All right. So this, I'll give you a simple analogy here. So if you have, let's say, 200 pounds or 50 pounds dumbbells, and you have 100 pounds of 0.2 an apple, which each weight 0.2 pounds. Now you know that if you arrange like a basket that has 1 dumbbell, 1 apple, we have only 4 of the dumbbells, but we have like I don't know how many, 500 apples. So the weight actually doesn't tell you the real amount, right? The real amount is going to be considered by in mole, so you will know that in mole. But the weight, this guy sulfur trioxide is really heavy. Each one of them really heavy. 20 grams, that's not a lot, right? 0.204. Water is really small and light. 10 grams of water, that's a lot of moles. Okay. All right. If you want to do in okay, here we go. All right, so to convert moles of sulfuric acid to moles, sorry, my bad. If you want to convert the moles of sulfuric acid to grams of sulfuric acid, you just use molar mass, and that's it. Moles cancel out, moles at the bottom, and you get that number. Okay, round them down, 24.50 grams of sulfuric acid. All right, so all right. Now, let's try this one. So, how much glycerin, so C2H5NO2, could be expected in gram from the reaction of 29.3 grams of carbon dioxide right here and 4.53 grams of ammonia? If you look at the equation, there are 3 reactants. This question doesn't say anything about CH4, methane, so you can assume that that's excess. All right. Okay. Now, what does the question ask us? How much glycerin? So this guy could be expected. Expected. That's a theoretical yield. Basically, it just asks what's a theoretical yield with from 29.3 grams of carbon dioxide and 4.53 grams of ammonia. Okay. First of all, make sure that if the reaction is balanced, 1 carbon, 2 carbon, good. Hydrogen is everywhere now. 1 nitrogen, 1 nitrogen, 1 carbon, another carbon. So 3 carbon left, 3 carbon on the right. Good. Oxygen. So 2, 4, 5. 1, 2. Oh no, sorry. 2, 3, and 4. 4 oxygen. Good. I'll be good. All right, now find the limiting reagent first, okay? So we're gonna look at the reactant in here. So CH4, assume that we use excess, all right? So we have 29.3 grams of carbon dioxide and 4.53 grams of ammonia. Convert that to mole first, both of them. Ta-da, all right? So divided by molar mass, you get it right away, okay? All right, who's more, who's less? Looks like we have a lot more carbon dioxide, but what we use two times as fast as ammonia. So we use this guy use up more quickly. Okay. All right. Let's say who's gonna run out first. Well, totally probably have to be ammonia here. All right. Let's say if we use up ammonia, use all up. All right. Use them all up. 1 mole use this 0.2658 moles. All right. 2 moles gonna be double that amount. All right. And glycerin, so it's 1-to-1 ratio, 0.2658 moles here, 0.2658 mole there. Okay. All right. Subtract for the reactant, you should get 0.1342 moles left for carbon dioxide, and the ammonia go to 0, and we produce that amount of glycerin. Here we go. Okay, so ammonia is the limiting reagent, so which means that this guy will control the theoretical yield. All right, so we don't use carbon dioxide here because carbon dioxide left over. If we use the amount of carbon dioxide, you're gonna have way too much glycerin, which that's not happening. The reaction stops when the limiting reagent is used up. Okay, so the limiting reagent controls the amount of the theoretical yield. All right, so we're gonna take this guy, convert in moles to grams. So gram of glycerin that the question asks us, and we have mole of glycerin. So put moles at the bottom, grams at the top. So do molar mass, and do the math there. All right, this is 3 sig fig. So 1, 2, 3, 3 sig fig, 19.95. So 5 round them up, 20 grams of glycerin. All right, so that's the you can do the way I just showed you before, or this way. You can do it this way. I usually prefer this. Okay, and let's see how do I do this. So just pick one, the one that you feel more familiar, more comfortable with. Okay, so same question. All right, so we have 29.3 grams and of carbon dioxide and 4.53 grams of ammonia. Now ask for the theoretical yield in grams of glycerin. Okay, so basically I'm gonna use both of this gram, but do one by one to 5 grams of glycerin. All right, so start with ammonia. Let's say we don't know which one is limiting reagent, so start with ammonia. Do both of them, so we can convert grams of ammonia to moles of ammonia. Right, I'm sure you can do that as molar mass, and moles of ammonia to moles of glycerin, and moles of glycerin to grams of glycerin. You can do that. Okay, this way might be quicker for some people. All right, take a look. So 5 grams of glycerin, what we have 4.53 grams of ammonia. All right. All right, convert to moles of ammonia first. Use molar mass, put grams at the bottom. Gram cancel out. And then, so we have moles of ammonia now. Now, moles of ammonia to moles of glycerin is they're 1-to-1 ratio. Look at the coefficients. All right, so 1-to-1 ratio. Put moles of ammonia at the bottom. Mole cancel out. Now we got moles of glycerin. Now from moles of glycerin to grams of glycerin, use the molar mass, put moles at the bottom, grams at the top. There we go. And you should get that number. All right, round them off, you get 20 grams of glycerin. Now, we're not done yet, so we don't know which one's the limiting reagent, so we have to do both. So we're going to do carbon dioxide, convert to moles of carbon dioxide first, and then convert it to moles of glycerin, and then go grams of glycerin, right? This is supposed to be carbon dioxide. I don't know why it's potassium. It's so weird. Okay. Anyway, glycerin right here. All right, so 29.3 grams of carbon dioxide. So that's what we start with. Convert it to moles of carbon dioxide using molar mass. Right? This one will get you to grams, to moles of carbon dioxide. Now, next one, watch out that this is 2-to-1 ratio. Yeah, 2-to-1 ratio. So 2 moles of carbon dioxide at the top, at the bottom, per 1 mole of glycerin. Okay, and then glycerin, same thing. Use molar mass of glycerin, moles at the bottom, grams at the top. Cancel out. You should get to, here we go, 24.9925, blah, 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 and 3 sig figs, round them up. Totally. And ammonia ammonia produce less glycerin. This guy's a limiting reagent. And this is a real theoretical yield. Okay. Yep. Yeah, you could do this way too. I usually prefer this over what I just showed you earlier, but you can do either way. It's up to you, whatever you feel comfortable. All right. Let's practice together. Do this on your own. Check with me on the next video.